Hi folks, this is a predictions video for Leaving Cert Ordinary Maths Paper 1 for 2024, what comes up every year. So first of all, similar to the videos for higher level that I put up, this isn't, I don't have any information as regards what exactly is going to come up for this maths paper in 2024. It's simply my opinion, and it's just analysing a little bit of what came up there in the last few years. So there's no guarantees with it. So what's included? So it's an overview of topics which have come up in the exam papers for each of the last 4 years. So I'm going to put up a spreadsheet in a minute, which just goes through the general kind of topics of what has come up, and which obviously gives us an insight into what might come up hopefully this year. A list of recurring topics to focus on. So I've got some worked solutions to exam questions on these topics, and then I've got links and QR codes to full video solutions which I have here as well if you want to look at them, just to get into them a little bit further. Right, so this is a general year by year list of the overall kind of topics which are coming up, and I've broken them down and I've called them different things. So if you look in the first one here, so question 1 in 2023, so for example I've called it part A of the question percentage increase, so I've just called it whatever comes to mind, so there's nothing scientific about it. If you look at question 2, then complex numbers conjugate, plotting an Argand diagram. So it's generally, when I looked at the question, it's generally what I kind of summarized it into. So I'm going to go through a list of general topics which I think are important, and they should give you a starting point for your revision. They're not everything, but if you definitely, to pass the paper, you have to know these topics that I'm going to go through now. So the first one is finding percentages, percentage increase, and this is a general kind of one. Finding percentages comes up an awful lot throughout the paper. So if you look there, question 1 in 2023, so part A was percentage increase, part B was percentage increase, so working out percentages. If you go down even further, calculating tax and calculating percentages in question 10 there as well in 2023. If you look at 2022 then, so net income tax, so anything to do with tax, income is always going to do with calculating percentages. Finding percentage comes up in question 8 as well in part A, and then there's more about tax in question 10 as well. So percentages comes up quite a bit throughout the paper. There you've got a VAT question for 2021, so VAT is very similar to other kind of like income tax. It's all calculating percentages and being comfortable with them and understanding how to find them. And then in 2020 it's question 1 again, so it's financial maths, so percentage of an amount there comes up, and compound interest, just slightly different actually, comes up in 2020 as well. Right, so here's the question for last year. So this came up as question 1 last year. This is just the A and part B. I think part C was maybe where you're subbing in or something like that. But so by the start of 2020 the house price was increased by 8%, and then by the start of 2021 the price of the house was increased by a further 9%. So I'm actually missing the first part of that question. So the original house price of the house was 24,000. That's what it is up above. So you're just finding 8% of it, which is works out there to be 19,200, and then if you subtract that, if you add that on, then it gives you 259,200, and then you have to find 9% of that. So the way I've done it here, or described it in the video, is I've just multiplied by 8 and percentage button. Now what you might do is you might change 8% into a decimal. If you do, it should be 0.08, not 0.8. 0.8 would be 80%. That's a big mistake that people will make there. That's always the danger with turning it into a decimal. Or if you change it into a fraction, it'll be 8 over 100, and then you can divide by the bottom, multiply by the top, and so on. But you're just finding a percentage and adding it on. And then the second part of it, you have to find the percentage increase, so that ends up being 12,000 altogether. So you're putting it over 460,000, and then multiplying it by 100. That's not too bad. It's just working out the percentage increase, but you have to know to represent it as a fraction of the original amount, and then multiply by 100. So there's a QR code there. There's a video on that full question if you want to look at it more deeply, or just go through it a bit slower, and there's a link there at the bottom as well. The next one is complex numbers. Now I've included a big list of things here with complex numbers. I'd advise you to know how to do all of these things, because complex numbers is pretty much a guaranteed question. It's a full question, always on paper 1 as question 1 or question 2 usually, and there's not that many things in it, and I think students generally like it as a topic. You see the first thing there is plotting on the Argand diagram, and this is the question from last year. So plotting on the Argand diagram is fairly easy. It's just going right or left and then up or down depending on what complex number it is. Subbing in and simplifying, that's, if you look at the part 3 there, that's where you have to write 4z2 minus 5z3. So you're just putting in what z2 is and putting in what z3 is, and then you have to multiply them out and simplify. So that's an example of that came up last year. Conjugate and modulus are actually quite easy, it's just they're hard to remember. Part 1 there, plot and label Z1 with the little line above it. So the little line above it means conjugate. You have to know that, and all that conjugate means really is that you change the sign in the middle. So Z1 here was 3 minus 3i. So the conjugate of it is 3 plus 3i. And that's all conjugate is. The modulus, that's where you do the square root of, and then you square the two numbers inside and add them together. And then you've got rationalizing the denominator. That's goes on, it's a little bit harder then. So you're multiplying top and bottom by the conjugate of the bottom. And then the last part is subbing into quadratic, just to show that it's a solution. So obviously I'm only barely describing what those things are. You need to look into them in more detail, but they're definitely worth knowing. So I'd always encourage students to learn off complex numbers and try to do really well in that question. This is the rest of that question, and again there's a link there to it. This is the rest of the question from last year. So that part there at the top is the modulus of Z3. So that's what I was just saying there. So so Z3 was 6 minus 2i. So to get the modulus of it, you do the square root of, and then you do 6 squared plus minus 2 squared inside, and it works out being 2 root 10, and that's the modulus. The part B last year was an interesting kind of question. It was a little bit unusual. You had to say which one has the largest modulus, so it's testing you on if you actually know what modulus really means. So modulus, what it actually calculates is how far away from the origin a complex number is. So if you look at all those complex numbers there, I've drawn a red line out to each one. The Z5 is obviously the furthest one away from the centre, so a lot of students would have guessed that even if they didn't really know it beforehand. Z5 kind of looks like it's out by itself anyway, so might have given you a clue there as to why, and the reason is just that it's furthest from the origin. So that's complex numbers. The next one is minus b formula. Minus b formula is used to calculate or to work out a quadratic, to solve a quadratic. This is the question from last year. Solve the equation for x and give your answer. Give each answer correct to 2 decimal places. By saying correct to 2 decimal places, it's giving you a clue as to that you have to use this. But you should be able to recognize a quadratic. Quadratic is when you've got an x squared term, an x term, and a minus, and a term by itself, just without any x, and equal to 0. So your a here is the 9, your b is the 6, and your c is the minus 5, and you just put them into the minus b formula. It's in the log tables, you don't have to learn it off fully, but you have to be comfortable with it. And then when you're subbing in, I always advise put everything into brackets when you're subbing in, and go straight to the calculator from here, especially if you're not comfortable too much with your signs, multiplying out signs, just so you won't make a mistake. Put it in with a minus first and then put it in with a plus, and again there's a link there if you need to see it. You'll see here that minus b formula came up in question 6 in 2023. That was the question I just shown you there. I'm pretty sure this comes up every single year. It comes up in question 7 there in 2022 in part F of it. In 2021 it comes up as question 3. And then does it come up in 2020? Yeah, so part A in 2020. So minus b formula has come up every year for the last 4 years. So it's definitely a question you need to understand, need to be able to do. Next one is simultaneous equations. Again, it's part of algebra. Now, for the last couple of years, this has come up with where they're both linear, so it comes up like this. Now, these are actually the easier types of simultaneous equations. The other one is the one with non-linear. That's where you've got x squared and y squared terms in it in one of the equations, and you have to solve sub in the linear one into the non-linear one, and they're a little bit harder than these. This one is the one from last year, so just see the little arrow above bringing the 1 over there. That's what you have to do first. You have to bring over the 1 and call the minus 1, and then you can put 1 over the other, and then you're multiplying the top equation by 4. So remember, you have to multiply everything in the top equation by 4. So 4x and then minus 4y and then minus 4. Then you can cancel out the y's, you add going down. 6x equals 15, and then x ends up being 5 over 2, so you get a fraction, and you sub that back in and get the y value. So simultaneous equations come up in question 3 there in 2023. Then in 2022 it comes up in question 2 there, part C as well. That was very similar to the one last year. And then in 2021 simultaneous equations non-linear comes up, so it's not like those ones. They're slightly harder how to do them, but I definitely look up those as well and be able to do them. And then in 2020, pretty sure it comes up again. Yeah, so part B there for question 2 in 2020. So simultaneous equations, one of the types came up there every year, so you have to be able to do that. This is solving linear equations. So this is where you're basically moving all the x's to one side and the numbers to the other. Now in this one, you have to multiply out the brackets there first. So 3 times 2x is 6x, 3 times 4 is 12, 6x plus 12, and you just bring down the minus 5 equal to 3. You can do 12 minus 5, which is 7, and then you can bring the 7 over, and because it's a plus 7 on the left hand side, it becomes a minus 7. So you get 3 minus 7, which is minus 4, and then you're dividing by 6 at the end, and that's it. Now this is really important. Even if it doesn't come up by a question itself, you have to basically solve linear equations even within something like simultaneous equations, and there's a lot more other stuff as well. You could have to solve an equation in functions or in sequences with nth term where you have to solve for n. So if you look here, that was part A of question 3 last year, 2023, and then solving a linear equation. So something similar to that was question 2 there in 2022, and then yeah, so it comes up in 2021 there, question 4. And then doesn't come up exactly like that in 2020. Algebraic fractions actually comes up there in part A, and then you have simultaneous equations in part B of the algebra question. But if you look there at part B in question 8, even that year, it's subbing into a function and solving, so it's still going to be moving things across the equal sign and solving for a variable. So it's a really important skill to be able to do, is just be able to move the x's to one side or whatever variable it is and numbers to the other side. Know that you're doing the opposites on both sides of the equation. Right, next one is arithmetic sequence and sum of arithmetic sequence. Now, interestingly enough, this didn't really come up last year that I could see when I was going through the paper. So I've just put in, but it's a really big topic, so it was very unusual that it didn't really come up. So it came up in 2022 and all the other years, so I'd really be expecting it this year again. This is the question from 2022. The first one was you were given Tn here, so sometimes you might have to find what Tn is, find what the nth term is. But here you were given Tn and you have to find T1. So all that means is you put a 1 in instead of the n. So that's what I'm doing here. I'm putting a 1 in it. And for this one, when you put 1 in, it actually does 1 minus 1, which is 0. And you times that by 4, so 0 times 4. So it kind of cancels all of the second part out, and your answer is just minus 254. Second part is find the value of the common difference of the sequence. And they give you a big clue here, that is T2 minus T1. So all you have to do is find T2 and find T1 and then subtract them. And you've already got T1 found out here because you've done it in the first part. So T2 ends up being minus 250. So you do minus 250 minus 254, which is 4. So the common difference is 4. So in any arithmetic sequence, if you do the second term, take away the first term, it's obviously going to give you what the difference of them is. So that's what the common difference is. The last part, the part C of this question, I think the part B was solving an inequality, but part C was using this formula, this Sn, this n over 2, and that's a formula that's very important. You have to be comfortable with that formula and understand what n is, and where to put in the A, where to put in the D. So just be able to understand. But in the context of this question, it came up where you had to just solve for n, and the reason I'm cancelling out the n over 2 there is because I'm bringing it across the equal sign and dividing, but you're just dividing it by dividing 0 by it. So therefore you can just cancel it out. And then it's just moving things across. So again, it's an example of solving a linear equation. It's moving the minus 508 across, it becomes a plus 508, and the minus 4 across, and it becomes a plus 4, and then divide by 4 in the end to get n. So in here you're not actually putting things into that formula, but it's an important formula to understand. So 2022 there. comes up in question 6. And then 2021, you'll see again it comes up as question 6, finding terms and sum of arithmetic sequence. And then 2020 as well, it comes up as one of the long questions in 2020 actually. That was when there was only 9 questions on the paper, so it was question 9. So you just had to find the next pattern. I think that was where you had 3 images of patterns and you just had to draw what the next pattern looked like, which is actually one of the easier parts of the whole question. Part B, so finding terms, then sum of arithmetic sequence. So it's using that formula that I was saying just there. And then next pattern, an area of a triangle. That was the last part. That was kind of a hard part that you had to interpret for the part D. Right, so that's arithmetic sequence. The next part is differentiation. Differentiating a function. This is the question came up last year again. So you had to differentiate. I don't have the original function in here actually, so if you want to click into that video and just see it, it was just differentiating, and that. So I think the original function would have been x cubed plus 2x squared minus x, something like that. But you're just differentiating it. Then finding a slope of a tangent at a point. That's pretty much the first part of part 2 here, where you're given the point 26 and you're just subbing in instead. So you're just putting a 2 in instead of the x, because the 2 is the x value, and that gives you 19, and you're just putting that into the differential. So 19 is the slope of the tangent at that point. And then finding a max or min, I don't have an example here of that didn't really come up here in this question, but that's just another important part of differentiation. There's other things that can be asked on it as well, but I just threw those 3 things down. The last part here was to find the equation of the tangent, so not just the slope of the tangent. And by putting in the 2 and getting 19 is the slope of the tangent, but to get the actual equation of that tangent, you have to use that formula, the y minus y1 equals m, and you're putting in the 19 instead of the m then, and then the x1 and y1, you're just putting in the 0.26, because that 0.26 is on the line of, which is the equation of the tangent. So differentiation, really big topic, pretty much guaranteed there in paper 1 as well. The last thing I'm going to show you now is just subbing into a table and plotting on graph. This is something you definitely should be getting marks for if and when. It's almost definitely going to come up in some way where you're going to be putting into some kind of a table. So here all you're doing is you're just putting in what the t value is in this case. So the first t value is 0, and you're just putting a 0 in instead of the t, but the t is actually in the power here. So you should be okay on putting it in the power into the calculator, but here you just have to put in 2100 multiplied by 1.18 to the power of 0, and that will give you 2100. Then you do exactly the same thing with a 2100 multiplied by 1.18 to the power of 1, and it gives you 2478. And then so on, you just put in a 3, a 4 and a 5, and it gives you all those numbers. And then the next part is just putting it on the graph. So it's just plotting the point 0, 2100, 1, 2478, and so on. I've got them as kind of red dots there, and then you're just connecting up the line, and that's all it is. And that's 2 parts of a question, and I think that's part of the long question as well. I didn't go through this for differentiation actually, but yeah, so you see they're filling in the tables for question 9 last year. Subbing into a table from a function is question 7 there, 2022. filling in a table there for question 8 in 2021 as well. Yeah, I can't see it straight away there for 2020. Just to go back and just look at differentiation in here. So differentiation was question 7 last year. Then it came from question 10 in 2022, and it came up in question 4 as well in 2022. And find an equation of a tangent. Turning point came up there, so differentiation in question 5 in 2021. And differentiating a function, basic function, subbing in a point, find an equation of tangent again in question 6 in 2020. So you'll see that all of those topics I've gone through are generally coming up pretty much every year. Maybe missing one here or there, and again, they're not a list of overall topics or anything like that, but I think they're just a good place to start. So if you wanted to start studying maybe with a couple of months to go or a couple of weeks to go or whatever, and you haven't really done much so far, these are the ones I'd be getting stuck into. Know all of those, and then you can move on, look through exam papers, look at other parts of the course. So that'd be my advice. So that's it. That's all for this video.